Hello all, welcome back. And this video is all about QuickSort algorithm, which is again one of the applications of divide and conquer method. Okay, so here in this QuickSort also we are going to apply divide and conquer, where the partitioning of elements in the array is happening based on the pivot element, and we are going to define two variables here. One is I, the other one is j, which is going to indicate the index values of the array, right? So based on this we are going to partition the elements of the array, and then we are performing sorting here. Okay, so now let's see this with an example. And see, this is the example I have taken where we have unsorted list of values, and here coming to the pivot element, I'm taking the starting element as the pivot element, and coming to the variable I, I'm assigning that start plus 1 as the ith element, and coming to j, you can see, which is the end element. So I have taken j as the end. This I and j indicates the position of an, that is index value of the array. Okay, so here the index value of I starts from 1 and the index value of j is at array size minus 1. Okay, so this is how I have taken the pivot element I and j. Now what are all the conditions we need to check for QuickSort algorithm? Okay, so here I have come up with 4 conditions. You can see the first condition is you need to check whether the array of I value is lesser than the pivot element. Okay, if it is less than pivot element, then we need to perform increment of I. Okay, that is I plus plus. Otherwise stop. After that, you need to go and check for this condition, that is whether a of j, that is array of j value, is greater than the pivot value. If it is true, then we need to perform j minus minus, that is decrement the value of j by 1. Otherwise stop. Okay, and the next condition, once you stop doing these two process, after that is the third condition, that is you need to check whether the value of I, that is the index value I, is lesser than the index value j. If it is lesser value, then what you need to do is you need to swap the elements of the array A, okay, that is present in the position I and in the position j. So like we are going to swap the elements that is present in the position array and position j. So the jth position element will be moved to ith position and the ith position element will be moved to jth position. Okay, so this will happen only if the value of I, that is the index value I, is lesser than the index value j. Otherwise, if the value of I is greater than or equal to j, then what we are doing here, we are swapping the value of j, that is a value present at the position j, with the pivot value. Okay, so once you are swapping the pivot value and this jth value, that is jth position value, then in this point we are going to partition the array. Okay, so basically the partitioning of array happening in this case only, right? So now we'll take this example and we'll solve, and meanwhile I'll explain you like where the partition is happening and how it is happening. And here is the example taken. So in this example, as I mentioned, I have taken the first starting element as the pivot element and start plus 1 as I and the end as j. Okay, and here I and j indicates the index value of this array, right? And now first condition, what we need to check in the first condition, you need to check whether a of I is less than the pivot element. If a of I is less than pivot element, then we need to increment the value of I. Otherwise, we need to check for a of j. If a of jth element is greater than pivot element, then you need to decrement the value of j. Okay, these two conditions we need to check first. So here I am taking a of I. What is my a of I? That is 10. So you are comparing this a of I with the value pivot element 6. Okay, so here 10 is greater than 6, which is not satisfying this condition. Actually 10 should be lesser than 6, but it is not satisfying the condition. So if it is not satisfying the condition, then stop here. Go and check for the next condition. What is the next condition? A of j value should be greater than pivot element. So what is A of j here? A of j is 11 and your pivot element is 6. So here A of j, this 11 is greater than pivot element, which is true. Right? So if it is true, what we need to do? We need to decrement the value of j. So here I am going to decrement the index position of j. So if I decrement this, in j will be like position will be here, moved here. So that is what happening in this next step. Okay. So in this step I didn't move I because the condition is not satisfied here, whereas coming to the condition of j, it gets satisfied. So I just decremented the jth position. Now again, after decrementing the jth position, you need to repeat the process again. That is, you need to compare this A of j and pivot element again. So here I am comparing A of j. Now A of jth element is 2. So 2 is greater than 6. You are comparing that, you are checking that 2 is greater than 6. No, it is false. So if it is false, no need to do this, just stop here. Okay, so once you stop the I and j, okay, after that, what is the third condition you need to check? You need to check whether the index values, that is I, is less than j. Okay, so if I is less than j, we need to swap A of I and then A of j. Okay, otherwise what you need to check? You need to check I is greater than or equal to j. If suppose I is greater than or equal to j, then here we are swapping pivot element and jth element, that is the element that is present at the jth position. Okay, so this is what we are going to check now. So now after this, you are checking whether I value is less than j value. So you can see the index of I here is 0. The index value is 0. And coming to j, so you can see 1, 2, 3, 4, 5, 6. So the jth index value is 6. Right? Now we are comparing I value and j value. So here I value 0, j value 6. So it is satisfying this first condition. I is less than 0. Sorry, 0 is less than 6. That is I is less than j. If this condition is satisfying, then what you need to perform? You need to perform swap on the element present at ith position and the element present at jth position. So that is what the condition we have got here. So I is less than j. In that case, what I have done, you can see the element that is present at the ith position and the element that is present at the jth position gets swapped. So 2 and 10 get swapped here. Right? So this is what the next step. Now after swapping this, what you need to do is, again you need to start from here. Okay, you need to start from this first condition. Now this is your new position of I, that is a new element at ith position, and this is a new element at jth position. Again start doing this comparison. Okay, so now what is A of I? What is A of I? It is 2. And what is a pivot element? It is still 6. So you are comparing 2 less than 6. Yes, it is true. So if it is true, you need to move the I towards right hand side. Okay, which means you are incrementing the value of I. Okay, so I moves here. Again you need to compare these two values, that is A of I is lesser than this value. Yes, A of I is lesser than the pivot value. In this case, again you need to increment the value of I, so the ith position will be moved here. So that is what given here. Right? So first you compared with this, it is true, so you incremented the value of I. Again you compared these two values, and this is lower value, lesser value. Then again you are incrementing the value of I. Again you are comparing 6 and 8. And here if you see, 8 is greater than 6, which is not satisfying this condition. So if it doesn't satisfy the condition, then stop right there. No need to increment the value of I. So I stopped here. Now once you stop with I, next you need to go for this jth condition. Okay, check the value of j. Okay, the jth value should be greater than the pivot value. So here 10 is greater than 6. If 10 is greater than 6, you need to decrement the value of j. So now j value will be placed here. Right? Now again you are comparing 6 with 3. So this is not satisfying the condition. If it doesn't satisfy the condition, stop here. You stopped with I here and you stopped with j here. Now once you stop these two process, then you need to check for the third condition. So again you are checking whether your I value is less than j. So here what is the index value of I? Now the index value of I is 3. Okay, and what is the index value of j? Now index value of j is 5, right? So 0, 1, 2, 3, 4, 5. And now you are comparing I value is less than 0. So the index value 3 is lesser than 5. You are comparing. Yes, it is true. If it is true, then you need to swap the element that is present at ith location and with the element that is present at jth location. So in the ith location, element is 8, and in jth location, the element is 3. So now you need to swap these two elements. So that is what in the next step. Okay, you can see 3 comes here and 8 comes here. Okay, so now this is I and this is jth value, right? And when this happens, when I is lesser than j. Okay, so now you swapped it. After this, what you have to do after this condition, again you need to go here. Okay, go back here, then again start with a of I lesser than p condition. Okay, now this is my I, so a of I value is 3, and what is the value of pivot element? It is still 6. So 3 is lesser than 6. Yes, it is true. If it is true, move your ith value, I mean ith position. Okay, now this is the position of I, right? Again you compare this value with this value. 13 is not less than 6, which is not satisfying this condition. So stop here. Then again move to j. Okay, now what is the value of j? 8. So compare j value with 6. Okay, now 8 is greater than 6. Yes, it is satisfying the condition. If this satisfies the condition, you need to decrement the value of j. So now j like jth position will be here pointing to this element 13, right? Again what you need to do, compare this 13 with 6. Yes, 13 is greater than 6. If it is greater than 6, again you need to decrement the value of j. So now your j value is here pointing to the element 3, right? Now again compare 3 with 6. So 3 is lesser than 6, which is not satisfying this condition. Then you shouldn't decrement j here. You should stop right here. Okay, so you stopped I value, which is presently in this location, and you stopped j here, which is presently in this location, in this position. So now you need to go for checking this condition. So whether I is less than j. No, from this you can see actually I crossed what? J. So j is here and I is here. Obviously it means that j value is less than the ith position. So this condition is not true. Then this condition is true now. Okay, this satisfies, that is I value is greater than or equal to j. Yes, I value is greater than j value now. You can see the index value. Okay, so what is the index value of I now? It is 4. And what is the index value of j now? That is also that is 3, right? So now I index value is greater than the jth value. If this is true, then what are all the elements we need to swap? Pivot element with what? A of j. Okay, so now what is my pivot element? Pivot element is 6. Okay, and this is my new jth position and this is my ith position. I need to swap this pivot element with this jth value, element A of j. So once I swap my pivot element, you can see here I swapped my pivot element with jth value. Okay, so once the pivot element shifted, like swapped in its from its position, okay, then you need to fix that position as the fixed position. Okay, you need to fix that position. This is my pivot element, okay, which gets swapped to this position. Now this is fixed, so hereafter you shouldn't touch this pivot element because it got its position, okay, in the right place, right? So now this is my constant, constant position. You shouldn't change this position. Now your array gets divided into two sub arrays. So this is the first part of the array and this is the second part of the array. Okay, this is where actually divide happens. You have partitioned the array into two halves. Okay, so one is before this pivot element and the other is next to this pivot element which you swapped now. Right, now keeping this constant, okay, keeping this pivot element position as constant. Now this is my new array, okay, new sub array. I need to consider these elements. Again I have to start taking the pivot element ith position and jth position in this new sub array. Okay, in the same way I need to consider this array as well, right side array as well, which is again a new array, like one more array, another array. Okay, and in this array again I need to take one pivot element, ith value and jth value. Okay, first let me complete this one. Left hand side, we'll take left hand side. So as usual, the first element, that is starting element, is taken as the pivot element. And then coming to ith position, that is start plus 1 is the ith one, and what is the end here? This is the end of the array, so that is taken as the j. Again you need to repeat the same process. First you are going to compare whether your a of I is less than pivot element. What is a of I value? 2, which is less than my pivot element 3. In that case you need to increment the value of I, so I moves here to this position. Okay, so now after this we don't have any elements, so we don't want to move this I. Again we don't want to compare this values. Okay, so stop here for I. Now go to j. So what is the condition for j? A of j should be greater than the pivot element. So what is a of j now? Which is 5. It is greater than the pivot element 3. Right, so this case satisfies. Then we need to decrement the value of j. If you decrement the value of j, so j comes to this position. And here also what happens, after this you don't have any elements, like before this you don't have any elements apart from this pivot. So what you are doing here, again you are going to stop the process here. Okay, once you stop this process, you need to check for the condition whether I value is less than j or I value is greater than or equal to j. So in this case you can see I value is greater than j. Okay, if I value is greater than j, what are the elements to be swapped? The elements to be swapped are pivot and the array of j. So that is what we are doing here. So if you check here, I value is greater than j. So what you are doing, you are swapping the pivot element with jth element. So 2 and 3 get swapped. Once pivot element is swapped with this jth element, then you need to fix that position. Okay, you shouldn't change the position and you shouldn't touch this element again. So if this gets fixed, okay, then this side element, like it gets again divided into a sub array, and right of it also gets divided into a sub array. But if you see this array, there is only one element in both of the array. So again we don't have any other elements to consider for comparison. So let this be fixed again, and this element is also fixed in this position. Okay, now coming to the right hand side of the sub array, like this is the next right side sub array. And this, in this array also we have taken starting element. So in the sub array, now this is the starting element. So I have taken this element as a pivot element, then start plus 1 as I, and then last element as j. As usual, you have to start comparing the value, that is a of I is lesser than pivot. Yes, it is true. If it is true, increment the value of I. Again, a of I is lesser than pivot. Yes, it is true. Again, increment the value of I. Now I here. Again, check the condition. 11 is less than 13. Yes, it is true. But you cannot increment I now because this is the end of your array. So you just fixed I here. Now stop I. Then go for j. What is the condition for j? This j value, that is a of j value, should be greater than the pivot element. But here it is lesser than the pivot element. So you are not going to decrement the value of j. Okay, so you need to keep the value, keep the position of j as it is. You are not going to change the position. In that case, you can see what is the I value and jth value. I value is equal to j. Okay, so which means this condition is becoming true now. I value is greater than or equal to j. So in this, I value is equal to j. What if I value is equal to j? Again we need to swap the pivot element with a of j. So here what is the pivot element? 13 is the pivot element, and what is j, a of j? That is 11. So here I swapped 11 and 13. So once the pivot element is swapped, you need to fix that position for that pivot element. So now this is fixed. Again I formed one more sub array. Okay, I partitioned this, and again I have one more sub array. Now consider this sub array. Okay, then you need to consider this element of the sub array as a pivot element, which is start, and then start plus 1 as j and end as j. sorry, start plus 1 as I and then end as j. Again start comparing with jth element and pivot element. Yes, it is true. Condition, first condition, 8 is less than 11, it is true. Then move I. Again 10 is less than 11, yes it's true, but still you don't, this is the end of your array, you are stopping it here. Then compare the j value, this is the j value now. So 10 is lesser than 11, so actually 10 should be greater than 11, but 10 is lesser than 11, then in that case it is not satisfying the condition, so you are not going to decrement the value of j. In this case also you can see I is equal to j. So what if I is equal to j? Again same condition that you should swap pivot element with a of j. So here what is the pivot element? 11 is the pivot element, and what is the element that is present at jth position? 10. So swapping 10 and 11. You swapped pivot element now. So once you swap pivot element, this should be the constant position for this value. Now what is my subarray? Again my subarray contains values 10 and 8. So this is considered as my pivot element, and this element has the points both I and j. Okay, so this I and j points to the same element 8. So here also I is equal to j. In that case you need to swap pivot element with this element. So I swapped 8 and 10. Now the position of 10 is also fixed, and then we are left with only one element 8. Okay, so when you write down all these, at last you will get the sorted array. So first 2 and then 3 and then 5 and then 6. After that you have 8, then 10 and then 11, and finally we have 13. So this is my sorted array. So this is how a QuickSort works. So here I have considered my pivot element as the starting element, first element of the array, right? So based on that, how this algorithm works. Okay, so now we'll check the algorithm, like we'll check the code. How does the code works? Okay, how do we write code for this problem? So this algorithm is also having two functions, that is two methods. The first method is QuickSort. Okay, inside this QuickSort you need to check whether your end minus start is greater than 1. That is if you have more than one element in the array. Okay, so if in that case what you are doing, you are going for partitioning. Okay, first you are going to do partition. So how we are going to do partition? Based on the pivot element, by considering or by defining variables I and j. Okay, by doing comparison, and when the pivot element is swapped with the jth element, then the partition happens. So we need to do partition first. After that again you are applying the QuickSort for that partitioned element. Okay, whatever is partitioned here, that array element should be again applied to the QuickSort. Okay, so this process continues recursively. So here you can see the recursive calls. Right, now we'll check with this function partition. So how does this function partition works? So it's very simple, because we have already seen all the conditions and we have seen what are the elements that we considered for that, right? So now taking my first element, that is pivot element, and pivot element is always the start element. So in that array, that is, I have taken the array name as a list. Okay, so in this A list, the starting element is taken as what? Pivot element. And what is the value of I? That is start plus 1 is considered as I, and then end is considered as j. So first you need to check whether I is less than j, which means there should be elements in the array. Only if there are elements in the array, then you can perform this action. Otherwise, if I is less than, if I is not less than j, then you cannot perform these actions, because there were no elements in the array. Okay, so now what you are doing, you are going to check the condition that whether a list of I is less than or equal to pivot. So if the element that is present at the ith index is less than or equal to pivot, you need to perform what? I plus plus. Okay, so when you are performing I plus plus, until when you want to perform. So here I am using while loop. Okay, inside the while loop I am checking the condition and I am performing I plus plus operation, because you need to do this process repeatedly until this condition fails. Okay, so once the condition gets fails, you are not going to increment it, you are going to stop the process and you will be proceeding with the next jth element, right? So in the same way, you are going for j. Okay, and the condition for j is it should be, that is a list of j should be greater than or equal to pivot element. So if it is greater than or equal to pivot element, then you are going to do decrement operation on index value j. Okay, so until this condition becomes false, you need to do this process continuously. Okay, once you stop ai plus plus and j minus minus, then again we are going for checking the condition whether I is less than j. So if I is less than j, what are the elements need to be swapped? A list of I and a list of j needs to be swapped. So that's what happening here. You are swapping the I value with j value and j value with I value, right? And what if I is not lesser than j, which is the next condition? Else, what if I is greater than or equal to j? That is the next condition. If this condition is not true, then what is the other condition left with? So we are left with I is greater than or equal to j. So that is what happening here. If I is greater than or equal to j, then what we will be swapping? We will be swapping the pivot element with a list of j. So that's what happening here. So you know the pivot element is a list of start element is the pivot element. So you are swapping a list of start with a list of j, and a list of j is swapped with a list of start. Okay, so this is how you are doing swapping, and finally you are returning the value of j. So this is how this algorithm works.